If we want to see the order of the activities in a project in a bit more detail, we can create what's called a precedence network. The precedence network, like the Gantt chart, will tell you a bit of the sequence that we just do the projects in, but it also tells you when you can do tasks concurrently. So what we see here is a precedence network, and this is a version called activity on the node. So that means each of these circles you see here, or nodes, represent the activity happening. There are other forms of precedence networks where the dots or nodes indicate the time in between. So there's other ways to represent a precedence network. We're going to focus on the activity on the node. And as we look at the project and all of its pieces, the first thing we want to be able to do is determine what is called the critical path. The critical path is the longest path through the network. Once we identify the critical path, it's going to tell us the soonest we can finish the project. So let's find the critical path in this example. So what we need to do is figure out all the different paths that we see on this chart. So for example, we can go from 1 to 2 to 4 to 7, right? That gets us here to here to here. That's one route. Well, we also have 1, 3, 5, 6, 7. Can you find other paths? 1, 2, 5, 6, 7. How about another path? 1, 3, 4, 7. So these are all the routes we can take to get from activity 1, designing our house and obtaining finances, all the way to activity 7, finishing the work. These are the different routes we can take. Well, let's look at how much time each takes. So see on this graph, you see the black numbers, those indicate time. And here we're looking at time in months. So 1, 2, 4, 7, well, activity 1 takes 3 months, activity 2 takes 2 months, activity 4 takes 3 months, and activity 7 takes 1 month. So 3 plus 2 plus 3 plus 1 says that 1, 2, 4, 7, that route takes 9 months. Well, what about the other one? 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. That's 3 plus 1 plus 1 plus 1 plus 1. So that's 7 months. 1, 2, 5, 6, 7. That's 3 plus 2 plus 1 plus 1 plus 1. So that's 8 months. And 1, 3, 4, 7, so 3, 1, 3, 1 is 8 months. Well, what does this tell us about how long it takes to build the house? Well, really, to build this house, we have to do all 7 activities. But we don't have to do step 1, then 2, then 3, then 4, then 5. What this tells you is that activity 2 and activity 3 can actually overlap in time. We can do part of it at the same time. And so because of that, we don't have to just add up the times for all 7 activities to determine when we're going to complete this project. Well, should we go with the lowest number? 1, 3, 5, 6, 7. Should we go with 7 months? Is that how long it takes to build this house? Well, the problem with using the lowest number is if we do 1, 3, 5, 6, 7, and we take 7 months, is that really enough time to finish the house? Well, it's not, because we actually have to do steps 2 and 4 as well. So they have to happen, and they take longer than parts of 1, 3, 5, 6, 7. So we have to take that into consideration, which means the earliest we can finish this house is going to be the longest path, because that's the path that takes the most amount of time. And so we have to do everything in the project, but we don't have to do it all one at a time. So the earliest we can be done is based on the longest path. So this house takes 9 months to complete. Now, as we look at the activities individually, we can figure out when's the earliest we can start each activity, when's the earliest we can finish it, when's the latest we can start it, and when is the latest we can finish it. So let's look at those definitions. The earliest start time is the earliest time, of course, an activity can start. The earliest finish time, we're going to find that by taking the early start time plus the time for the activity. The latest start time is the latest that our activity can start. And here, when we're talking about the latest it can start, it's the latest we can start without delaying the finish. So remember, according to our critical path, we can finish this house in 9 months. So when's the latest we can start an activity without it pushing us beyond the 9-month period of time? The latest finish time is going to come from taking our latest start, and we could then add to that the activity time. We can also work backwards from the 9 months it takes to figure out the latest finish time, and then from there get the latest start. So let's look at how this would work. Let's go back to this table here. Okay, and let's find the early start, early finish, late start, and late finish, and let's do activity 2. Okay, so here's activity 2. Now, let's start with an easy one, early start. When's the earliest you can start activity 2? Well, the earliest you can start is the second you finish activity 1. How long does activity 1 take? It takes 3 months. So the soonest we can start activity 2 is in month 3. Now, when's the earliest we can finish activity 2? Well, if the earliest we can start is at month 3, and it takes 2 months to do activity 2, then the earliest we can be done is 5 months into the project. So now we need to figure out the latest we can start activity 2 and the latest we can finish activity 2. So we said that the overall project takes 9 months to complete. So we need to make sure that after we finish activity 2, there's still time to do the remaining activities to hit our 9-month deadline. Which means to find the latest we can finish and then the latest we can start, we have to work backwards. So we'll start with 9 months and we'll work backwards. So if we are looking at the path where we go 1, 2, 4, 7, then when the 9-month deadline hits, we have to have already done activity 7, which takes 1 month. And we already have to have done activity 4, which takes 3 months. So if there's 4 months worth of work still left to do after activity 2, then the latest we could finish would be at month 5. Now this only takes into consideration this path here. But we have to recognize that after we do activity 2, we also have to do 5, 6, and then 7. So we need to look at that ending time of 9 months minus the 1 month for activity 7, minus the 1 month for activity 6, and minus the 1 month for activity 5. So if you look at that, then there's 3 months worth of work that has to be done after activity 2, which suggests that the latest we could finish would be at month 6. So which of these two numbers do we choose? Do we pick 5 or do we pick 6? Well, if the latest you finish activity 2 is, say, at month 6, then will you really have enough time to finish the rest of your project? Keep in mind that after you do activity 2, you actually have to do 4 and 5 and 6 and 7. If you look just at 5, 6, and 7, then sure, you only need 3 more months after you finish activity 2. But activity 4 takes longer time, and you must account for that as well. So when you do the latest finish, it's going to be the minimum of the numbers you calculate from the different paths. So in this case, the latest we can finish activity 2 is not 6 months, but 5 months. And this will allow us to do activity 4, 5, 6, and 7 after activity 2. Well, if the latest we can finish activity 2 is month 5, then we can subtract the time it takes to do activity 2 and find that the latest we can start is at the 3rd month. Now notice the earliest start and the late start are both 3 months, and the earliest finish and the latest finish are both 5 months. What this tells you is that there is no slack. If there's no slack, your early start equals your late start, and your early finish equals your late finish. There's no room in there, no wiggle room to delay activity 2 at all. And the reason that there is no slack in activity 2 is because activity 2 is along your critical path. Whatever's on your critical path will have no slack, because those are the activities that take the most amount of time and are impacting your ability to finish the project. Let's look at activity 4. So for activity 4, what's the early start, the early finish, the late start, and the late finish? Okay, we can start with early start, and we are looking at activity 4. So now we're looking at this one here. Now notice that there are multiple paths to get to activity 4, right? We can do 1, 2, then 4, and we can do 1, 3, then 4. So when we look at the earliest start, we have to consider the path that's 1, 2, then 4, means we take 3 months plus 2 months, and so the earliest we can start activity 4 would be at month 5. But if we go the other way, and we look at activity 1, then 3, that's 3 plus 1, and the earliest we could start then is at month 4. So which one of these numbers do we use? Well, if we start at month 4, you start constructing the house, has everything been done that you need done to that point? Well, remember, we actually need activities 1, 2, and 3 done before we get to activity 4. You need a foundation before you can start constructing the house. So if we start at month 4, that foundation's not done yet. So when it comes to early start, we're going to go with the maximum that we get from going down those different paths. So we're going to get the bigger number of 5 and 4. So the earliest we can start here is month 5. That will allow us to do both activities 1, 2, and 3. Earliest finish, well, if the earliest we can start is month 5 and activity 4 takes 3 months to do, then the earliest we're going to finish is 8. Now let's look at late start, late finish. So the latest we can finish, we take our 9 months and we subtract the activities that come after activity 4. Well, there's one activity after activity 4, which is activity 7. It takes 1 month. And notice that that's the only route after activity 4. So we don't have to do any mins or maxes. In this case, the latest we can finish activity 4 is to give enough time to just do activity 7 after it, which takes 1 month. So the latest we can finish activity 4 is at 8 months. So when's the latest we can start activity 4? Well, if the latest we can finish is at 8, and it takes 3 months to do it, the latest we can start it is at 5. Well, what do you notice about activity 4? The early start is 5, the late start is 5. The early finish is 8, the late finish is 8. So how much slack is there for activity 4? Could we delay the start of activity 4? Could activity 4 take a little longer than we anticipate? Well, remember, activity 4 is on the critical path, so it has no slack. Okay. Let's try one more. Now that you've figured out how this works, let's try activity 5. So take a moment, pause the tape, find early start, early finish, late start, late finish. And we're looking here at activity 5. So when we look at activity 5, early start, remember we need to go through the multiple paths to get there. So what comes before activity 5? Well, we can do activity 1, then 2. So that's 3 plus 2, which is 5. Or we could do activities 1, then 3, then 5, which is 3 plus 1, which equals 4. All right, do we go with the minimum or the maximum of those numbers? We go with the maximum. Make sure that we have enough time because we actually have to do activity 1, 2, and 3 before 5 can happen. So we need to ensure that there's enough time for all of it. So it's the maximum of 5 and 4, which is 5. The earliest we can finish activity 5. Well, if the earliest we can start is 5, and it takes 1 month to do it, the earliest we can finish is 6. All right, let's find the late finish and the late start. So again, we're working backwards. If the latest we can finish is 9 months, we need to work back to figure out what happens after activity 5. And after activity 5 is 6 and 7. 7 takes 1 month, 6 takes 1 month, 9 minus 2 is 7. Do we need a min or a max here? No, because there's no other routes after 5. There's just 6 and 7, so we don't have to worry about a min or a max. And so the latest we can finish is going to be 7. The latest we can start is going to be that 7 minus the amount of time it takes to do activity 5, which is 1. And so the latest we can start is 6. So what do you notice here? The early finish is 6, the late finish is 7. Early start is 5, late start is 6. Do we have any slack? Can activity 5 be delayed at all? Yes. And how much? Our slack here is 1 month. The difference between our early start, late start, or between early finish, late finish. They'll give you the same answer. You have slack of 1 month. So we could actually go through and we could find the amount of slack for each activity. So we had activities 1, 2, 3, 4, 5, 6, 7. Some of these are really easy because we know anything on our critical path, 1, 2, 4, 7, has how much slack? Has none. 1, 2, 4, 7. We just found that activity 5 has 1 month of slack. And we could find out how much slack there is in activity 3 and 6 as well. We would use the same process. By going through and finding the early start and the early finish. If you want to try those, then we'll show you here in this video the solutions to them. So what we see here for the activities is that you can see on the top the early starts, early finishes, and on the bottom the late start, late finish. So for example, here in activity 2, in this light green you see the early start is 3, and in this pink you see the late start is 3. So no slack in activity 2. Early finish is 5, late finish is 5, that's the blue, and you can see no slack. So as we look at the other activities, for example, we have activity 3 here. Notice that the early start is 3, the late start is 4, so there's slack of 1. So leave that up on the screen in a moment, just in case you want to try calculating the early start, early finish, late start, late finish for the other activities, and then here's the answers that you see here. All of that assumes that there is no variability in the time an activity takes to do. So in each of those calculations that we did, we knew exactly how much time it took to lay a foundation, or build a house, or select the paint. But what if there's variation in the time an activity takes? And that's what the next video goes through.